Hi, and welcome back to the Low-Level Devil channel's Build a Linux Distribution from Scratch series. In this video we're going to finish with the development of our simple package creator utility. If you haven't seen the previous videos in the series, please check in the description for a link to the playlist. So let's get started. So now when we left off we were printing out the YAML.pck file to the console. So let's go back to our pck C main.c. So we don't actually want to print it to the console, we want to write it to a specific file. So in order to do that, the first thing we need to do is actually create the directory structure. So what I'm going to start with here is, let's create a file name variable, say pck file, and we're going to use sprintf pck file, and we're going to use the root directory that we passed in up here as a parameter, or the default value that's set. Okay, so we're going to take that, and then we're going to use the first letter of the package name and then the package name itself. So we'll do %s /, which will be args.root, and then we're going to use %c, which will be the first letter of the, or actually repo, then %c, which will be the first letter of the package name, followed by the package name itself, and then .pck. So that would be the format of the package file location. So we're going to take pck.name 0 and then just pck.name. So that will be our full file name to the .pck file. Okay, now I'm going to use this function called access in order to find out if that file actually exists. Because that file already exists, that means we've actually already created this package. And when you get into the BLFS, the Beyond Linux from Scratch stuff, you'll find that there's so many packages you have to create and build that it's very well likely that you won't remember if you created one already. So rather than going through all this process, let's check and see if it already exists. And I'll just return -1 there. Now heading back to the common file, I want to create a common function, a simple one that will create a directory for me based on the package name. So this will kind of ensure that the directory structure exists. So I'm going to call it create package path. Okay, and it'll take a char pointer root and char pointer for the package name. So I'll create a char path. I'll just use 1024 for the size. I'm going to use sprintf, and essentially the same thing I did before. So, but except for on this one, I'm going to just create that very first subdirectory. So, for instance, in glib, it would be the repo/g. So with the root and then the name's first character. So we want to make sure that exists. So if access that path equals 0, or maybe it's not equals 0, just off the top of my head I can't remember, but we'll find out. So in that case we want to call makedir with the path. So we'll create that directory, and if that returns an error, actually we want to specify the permissions on it. We'll make it 775. So if that fails, we just return an error. Failed to create repo path. And that's it. And then we'll return false there. Now I'm just going to copy and paste that, and then I'll add name to it with %s/%s. So if that one doesn't exist, create it. And If it does, then just go on and we'll create this one if it doesn't exist, and return an error if that fails as well. So that will ensure that that path exists for us, because when we go to actually create that file, creating it's going to fail if that path doesn't already exist. So now let's take this and we'll put that in our header. There we go. Now going back to our main, we're going to call that function create package path. We'll give it the root and then our package.name. We'll do an if not, then return -1. Okay, now that we know that the path exists, we can use a file object, and we're going to use fopen on that PCK file, and we'll use W to make it right, and if not FP, that means that it failed to create it for some reason. I'm not going to get into all the different error handling scenarios here, but if for some reason it fails to create it, I'll just print that error out and return -1. And then we'll just use fwrite, which the first field would be the pointer of the string we want to write, so we'll put PCK file, or PCK stir actually, sorry. And size of, actually no, we should use strlen instead, so we'll use strlen PCK stir, and we'll just say 1, and then we pass the file pointer. Yeah, I guess we can do some error handling there, but yeah, I guess it's not that important. This is just a utility, so we won't check the error codes of these. You can, if you want to, check the size t value and ensure that the write succeeds. And for this purpose, I'm just going to write to it and close it. So that will create the PCK file for us, using that PCK stir that we did in the previous video. Okay, so now the next step will be to create a build file as well. So I'm going to call this one, let's see, just build file. And it'll be the .build. Everything else is the same. And I'm going to just copy and paste this because it's going to do essentially the same thing. I could make this a separate function, but it's really not worth it for the use for this. And I'll just say failed to create build file if it fails. And I don't want to write PCK stir. Now I don't want to write that same package stir, so what I'm actually going to use is fprintf. So fp, and then so what I'm going to put in this build file is just kind of like a standard template. So most of these, well, many of these will follow the same kind of pattern where configure, make and make install. So I'll just take this one as a base. So we'll say first line we'll do the configure with prefix equals /user. And then on the next line I'll do make, and then on the next line I'll do make install. Now we don't want to use a regular install though, we want to do a dest-dir install. So dest-dir equals $p. So $p is actually a parameter that we're going to insert into the environment in our build program. So right now $p doesn't mean anything, but eventually it will. So now that we have this file, we're likely going to want to edit this one every time. So what I'm going to do is create a new process. I'm going to call it vi. I'm going to use fork. So in fork I'm going to say, so if vi equals -1, So that would mean there's actually a error invoking VI. For instance, if you don't have it, if you don't have VI, you're not going to be able to execute it. You could use your own editor, whatever editor you like really, but I just prefer to use VI. And I'm also printing out the error number to see what the reason for the failure was. Now if VI equals 0, let me see, if VI is 0, I believe that's the child process, or if it's not 0. Just going off memory here, I should be looking at the documentation, but let's say we're inside the client, inside the child process, not a client. And now we're going to call execlp. So this is going to let us actually execute a program inside that process. So user bin vi or vim or whatever editor you want, just put the full path to it, and then this is a name for that editor, just say vim. So then we put the arguments, and let's see, for the arguments I'm just going to put the file name, I suppose. So build file and then null. So this is a variable argument, so you can put all the arguments and then null is the last one. So I'll say failed to execute vim and error no, and return -1. Let's just see if we can build this as it is. Yeah, user bin vim, that's the right place. Do I have too many, or I'm missing something there? Oh yeah, there you go. That should be a parentheses. Alright, and then after that, so after we edit the build file, first let's test it out to make sure it builds. And mkdir is something I'm missing. I think it's sysstat. Yeah, there we go. Alright, so let's clear build and run it. Yeah, let's just run that last one. Failed to create repo path. So it looks like I probably just checked the wrong return value. So let me just go back to, we are in common, right? Let me see. Let's see, -r LLD, so we're setting the root. Maybe that's what I forgot. Package already exists. Okay, so that would mean that I already created this one. Let's try a different one. Alright. I'll just take, we can do any of these really. Let me look in here for one. I can just take zlib for instance. Okay, so I'll create zlib, so this should create the z and then the zlib directory. And then it executed vi for us. You can make check and all that if you want to. There's a couple things that needs to run after we do the make install, so we'll copy these, put them after the make destdir install. And we don't want these to go to /lib, we want them to go to $plib, so $p, change all these regular root directory references to $p, because this is going to be in our package directory, and since we're putting it in /lib, we're going to make sure that that exists. Make dir -p $p lib, and then rm on this file here. This is just a static library, since we're not really using static libraries in ROS. can see there it's got zlib build and a package file. And I can cat that package file out, and I see it's got the right fields in the right places. No dependencies because I didn't add any. And right, so everything looks good there. Now I'm just going to kind of zip through this page real quick. Find one of these that needs an install file, so we'll add the install support as well. And I think shadow is a good one, so let's go to that one. So shadow. So this has a bunch of different things we gotta do. Some things before configure, then we configure, make, and make install. And then after that we need to run these commands down here. So we can do that inside of our install file. And then setting the root password, I'm not going to do that inside of a install script, but let's see, and that's another optional command that we can add if you want. So maybe I'll do that one. So let's run through creating shadow with our utility. Shadow, yeah, that's it. But actually first, before that, let's add support for the install. Let's see, back to the main. So these are our options. Let's go ahead and add another option at the end. Call this, let's see, install or add install with install. We'll use I as the short name. So this is the flag that we can add that will create an install script. Actually, yeah, I don't think we want that. So create install script will be our description. Create install sh. Okay, down here we just take the Q1, copy, paste it, change that to I, and I'll say with install equals true. And I'm going to have to actually, yeah, that's not a part of package. I'm going to have to actually create this variable inside of our arguments structure. Let's call it bool with install. Okay, yeah, that looks correct. So now we need to handle what happens when they pass that field in. So after this, we're going to do a check on that argument, see if the argument is set. Actually, also inside the child process, we want to call exit, and we just do exit 0. Anytime you're spawning a process, it's going to need to do that. Okay, so if args.withInstall, that means we want to actually create an install file too. And let's see, create another string for the install file. Do this, maybe just reuse one down here. Call this path, and we'll say char path 1024. So yeah, first we want to actually create make sure that directory is created, because there should be a .install directory, and then there'll be a install.sh inside that directory. Because we might want to have other files inside the install directory. That's why we're not just creating a simple script without a directory for it. And I'm just gonna steal some code here. So make dir, let me just paste this up here because I know that's going to need it. Okay, 0755. return -1 if that fails, and we'll print the error out. Failed to create installer path. Actually, we want to put std error there. That way it goes to the actual error out. Return -1. So let's see, that's the first step. Second step, we'll just copy this again. Put /install.sh after it. And we want to pretty much do this whole forking vi again. So we'll fork that again. Let's see, let's see, if vi equals 0, then we're in the child process. Yeah, to do extra error handling, if you want to, you can really do all this extra error handling. For now, I'm just gonna do this because it's just a utility again. And I'll just paste that in there. And instead of build file, we want this path. So now I think that we're ready to go now, so let's try this. Go back to our console, clear, let's see, rebuild, everything's fine. And now we're going to want to run this with shadow, which I took that shadow URL, and I'm going to do -I, which indicates I want an installer. And let's see, something's wrong in my handler there. So if you do --help, it'll show the output. Let's see, for I with install equals create. Yeah, so it thinks that there should be a parameter to I, but there shouldn't be. So I can fix that inside the handler. See right here, yeah, that should be 0 because there is no parameter to it. I just is a bool that means include installer. Oops. Let's go back down. Yeah, before I go back into this, let's find that vi equals 0, not equals 0. Not equals 0 would be you're still inside the parent, so equals 0 means you're in the child process. So else, then I'm still in the parent, and what I actually want to do is wait for that child process to finish. So when you're in the parent, that PID is not 0, it gives you the PID of the child process. So now I can wait on the PID of that child process, wait for it to complete. Because I don't actually want to go through and try to edit the install file until I'm done editing the build file. And I'll do the same up here. Then I think we're ready to test that. Okay, now I'll rerun GCC to build, and we got a warning, wait PID. I actually need to do one more include here. Okay, moving on down. Okay, let's just go ahead and build this. Let's see. Rebuild. Okay, now everything's fine. So let's clear. Going to remove any one that I'd already created when I did that initial one. Alright, so now the first thing that happens is build comes up. Lets me edit the build file. These few things are going to go before the configure. Alright, so I'll paste those in there. See, this goes in. A lot of times on many of these packages, sometimes you need to build things. So this one is for cracklib support. Some of these things are needed, some aren't, depending on different options. So let's see, and then touch user bin password. I don't know that I'm going to need that, but yeah, I'm going to replace my configure with their configure. Then we have the make install, and that should be it for the build file. Now when I exited that, immediately the install file comes up. So now I can edit the install file. So this is kind of just a way to save me from having to type these, edit things and all that afterwards manually. So I hope you again enjoyed this video. This is kind of the end of the package creation utility. I think in the next video we'll start working on being able to build these through the package manager. I might do a separate package builder, or I might make building a part of the package manager. Still haven't decided on that yet. So again, I hope you enjoyed this video. If you did, like, comment, subscribe, and thanks again for watching.